Intelligent Transportation Systems Podcast. Welcome to the ITSPodcast. This is episode 7 for November 2013. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. Take your favorite armchair and sit down because this is a special episode about the recent successful Intelligent Transportation Systems Society's flagship conference, the ITS 2013, that just happened from October 6 to 9 in The Hague at the Netherlands. It has truly been a conference to be remembered thanks to the superb organization of Professor Bart van Arem, who served as General Chair, the scientific lead of Professor Andreas Hegyi, its Program Chair, the rest of the organizing committee, and a big number of people, also volunteers, who contributed acting as associate editors, reviewers, and of course, authors. In this special ITS podcast edition, you will enjoy a number of testimonies on this great event, plus a very interesting interview to one of the keynote speakers, Professor Matthew Karlaftis, on big data analysis for ITS using artificial intelligence. So this is the plan. Let's start with the on-site recordings. We will hear now Professor Bart van Arem, General Chair. Then we have a cut recorded to Professor Andreas Hegyi and some more corridor comments from Professor Christoph Stiller, President of the ITS Society. Let's start! Well, we are now with Bart van Arem. He is the General Chair of ITSC 2013. Congratulations, Bart. Are you satisfied with the results?
Oh yes, evidently we're satisfied as the program is going at this moment. And actually, when you organize a conference like this, it's just intuition, and you feel like okay, it's my time to do service to the ITS Society, and I'm going to organize this conference. And next, you put together a great team with great volunteers and have a good program chair, have a good local organizing committee. Then things start rolling. And we had a great hotel, and then we were surprised by the enormous amount of submissions on papers that we have, and then things started to grow even further. So we had over 600 submissions, 400 papers accepted, and in the end the number of registrations was over 500. And I'm very happy with the organization here, all the people that helped. We just had a conference dinner, and it was also very nice in a nice location. So yes, I'm very satisfied, and I'm also very pleased also about the technical program that was here. So the papers were good, the presentation that I saw were good. The number of no-shows were very low, so it was very, very good. Also, possibilities of changing in the program or skipping from session to session. That was very good. You see several people hopping from session to session. So, in the end, what makes the conference successful is that the people that do research on the field of ITS, that they engage in debate and try to make the research even more stronger. And I think that is what's happening at this conference, and I'm glad to be part of that.
Okay, thank you very much again, and congratulations.
Thank you.
Okay, just one question to Professor Andreas Hegyi. He's serving as Program Chair for ITSC 2013. Well, Professor, seeing the numbers and the scientific quality, I would say that your hard work has paid off. Are you satisfied with the scientific menu we can taste here in your conference? I think you should be.
Yes, I am absolutely satisfied. We were very popular when receiving the papers. We received 635 papers for the conference, and we had a lot of choice to select the best ones, ending up with 81 sessions with more than 400 presentations, and 14 special sessions and 4 workshops or tutorials. And the sounds that we hear, or the responses, are really positive about the technical level of the session, so I'm really happy.
Well, congratulations on that.
Thank you very much.
Very well, we're now with Christoph Stiller. He is president of the ITS Society. Congratulations, Christoph. You have to be proud of what we are getting here. You have had a very interesting ITSC, beating all records with numbers of people participating, with the quality, with the technical quality, and also we have a very successful transactions, a very successful ITS magazine. So apparently the society is all just getting better and better. What do you think about that? Are you happy?
Yes, of course. Just after the banquet, it was a great experience to look in so many happy faces, more faces than we ever had at any ITS conference. We almost had 500 participants here. I'm very grateful to Bart van Arem, Andreas Hegyi and his team for organizing this great event. And the same for the publications that our society has. That's our ITS transactions, our ITS magazine and our ITS newsletter are in a better shape than ever. It's now official that that we have the highest impact factor among all transportation journals, and this is due to the hard work of editor-in-chiefs, associate editors, reviewers who spend voluntary working time to make thorough reviews and a certain high quality of our publications. I'm very grateful to that, and I encourage people to join our volunteering team and participate in the society.
Very well, thank you. Christoph, at the end of this year you finished your period as president for this society. Did you close it happily? Do you feel okay with it?
Oh yes. Javi, when I started becoming president of this society as president-elect 3 years ago, I was very happy and proud to be elected, and I've spent a lot of time during the last years for advancing the society, and now I'm very happy to pass this on to another person who's very dedicated, Matthew Bart, who'll take over presidency, and I'll support him next year as a past president to keep the society on the track we're on.
Okay, very well, thank you. And congratulations again.
Okay, thank you, Javi.
Hello again. I hope you are feeling the excitement we could perceive in the air at the Kurhaus Hotel in The Hague. During the conference banquet, some awards were delivered. The 2013 IEEE ITS Institutional Lead Award went to Mr. Chris Armstrong and Google's SelfDriving car team for institutional leadership in research, development and applications of advanced self-driving vehicle technologies. The 2013 IEEE ITS Outstanding Research Award was handed to Professor Mohan Trivedi from University of California at San Diego for research contributions in machine vision and active safety technologies for ITS. And the 2013 IEEE ITS Outstanding Application Award went to Professor Miguel Ángel Sotelo from University of Alcalá in Spain for their project called Visualize and its contributions in applications of traffic sign automatic inspection technologies for safer road transportation. We are trying to arrange an interview with Professors Mohan Trivedi and Miguel Ángel Sotelo. Regarding Google's self-driving team, Chris Armstrong was not able to assist to the ceremony, but we could record a few words from the engineer they sent. So let's hear that final on-site recording for this special episode. Well, let's talk now about Google's self-driving car team. Chris Armstrong is receiving the 2013 IEEE ITS Institutional Lead Award for institutional leadership in research, development and applications of advanced self-driving vehicle technologies. We're now with Mr. Andrew Chatham. He is engineering manager at Armstrong's team. Congratulations, Mr. Chatham. Can you please introduce yourself and your team to our audience?
Sure. So I work at Google on the self-driving cars, where I'm one of the engineering leads. I've been on the project since the very beginning, and I've been at Google for 11 years total. As a lot of people have probably heard, we built a fleet of self-driving cars which have driven over 500,000 miles in real-world environments, mostly in California. And we're really pleased to be receiving this award.
Very well. Mr. Charan, do you realize the role Google's playing regarding the global public visibility of autonomous driving research and development? I mean, not just for Google, but for all the scientific community working on this kind of stuff.
We are aware and we're really excited about it. It's great reading about our own projects, but it's also been really exciting seeing how much the publicity we've received has spurred interest in other people's efforts within academia or industry.
Mm-hmm. Can you please explain us how much of the technology you usually equip your vehicles with relies on external information sources like high-precision GPS or Google's digitized maps? And how much of it depends on locally acquired information like vision, landmarks, recognition, LiDAR, laser, etc.? What's the balance you usually use?
We take a hybrid approach where anything that we could feasibly tell the vehicles about what the world looks like before it arrives, we will tell it. That's only fair. When a human being drives out in the world, they're not driving out of a state of ignorance, and neither should our cars. Of course, once you've told them what the world looks like, their digital map, the job is then to figure out how the world is now different from how you expected it to be. The vehicles that you need to avoid, the pedestrians, there are obstacles in the road, were not there in the map, but are present in the real world. That's where sensors come in.
And how about communication? You know, there's that strong trend now in ITS about vehicles sharing their local information with the obvious example of connected vehicles. What are your thoughts on that? Is Google planning something about that?
We're definitely interested in vehicle connectivity, and our vehicles are connected to each other via the cloud. We're not currently using any V2V technology, and while we find that very interesting, currently our vehicles are so sparse that there's not really anyone else to talk to. But we are very interested in having the vehicles communicate with each other, and we do have them share information.
Okay, that's all. Thank you very much, and congratulations to you and to your group again.
Thank you.
Well, it's now time for our prime content. It's a very illustrative interview. We hope you enjoy it. Very well, we're now with Professor Matthew G. Karlaftis. He has been one of the keynotes at the IEEE ITSC 2013 conference. He has just delivered a fascinating keynote titled ITS Data Analysis and Artificial Intelligence. Matthew Karlaftis is professor at the School of Civil Engineering in the National Technical University of Athens. He has participated in a number of international research projects on topics related to artificial intelligence, urban transportation operations, and emergency response. He's also volunteered at a number of professional associations, serving in responsibility posts as some of them. Hello, Professor. Thanks for joining our show. Can you please introduce yourself to our listeners?
Hello, Javier. Good morning and greeting to your listeners. I'm Matthew Karlaftis, as you said, with the School of Civil Engineering in Greece. And most of my work has been in transportation systems. And again, most of it has had a quantitative background, basically in the area of statistics and some in optimization.
Great. Professor, what is big data analysis and what has it to do with intelligent transportation systems? I think you face that topic mainly through artificial intelligence. Please tell us.
That's an excellent question. How to describe big data? With big data, we usually imply all kinds of data in terms of size that we collect and that challenges current technology and current ways in which we gather this data. Usually, big data is governed by the 3 V's: velocity, variety, and volume. And when those 3 are high, data comes at high velocity, let's say real time, is a high variety with social media, sensors, cameras, and of high volume, then we have what we call big data. And, we live in a world that is very rapidly evolving. We live in a world where urbanization is intense. They project that in the year 2050, 70% of the Earth's population will live in cities. We live in cities that are much smarter. Everything is interconnected, from transportation to healthcare to telecommunications. And of course, with a tremendous development of technology, mobile internet, the Internet of Things, autonomous vehicles. So all these give us information, and they pose immense challenges on our existing analytical approaches, because the point is that we don't want per se to gather this data. The issue is to analyze it and make sense of this data. So many of the current approaches we have just cannot cope with the amounts of data and the question posed. So we propose, and a lot of researchers have worked with some of the techniques in artificial intelligence to tackle these problems.
Mm-hmm. And how is this different to traditional probabilistic-based methodologies?
I think that statistics provides essentially the fundamental tools for analyzing all kinds of data. But some of the statistical methods that we all know are necessarily constrained in the way they are. They need a functional form for the models they question. So one of the things we do is that we want to introduce flexible methods to traffic flow because, as we know, traffic flow phenomenal, hardly linear or deterministic, obviously. And these nonlinearity and non-deterministic or the stochastic properties have to be accounted for. So we think that a lot of these methods that are more geared towards nonlinear problems can cope with a lot of the traffic data.
Mm-hmm. And could you please draw some examples on how these systems will change the way we use transportation systems? For example, will we save commuting time through these kind of systems?
Well, I think these systems and the data that are produced, because I think that's what you're referring to, the data that are produced, will change the entire world we live in, right? They will not only change transportation. I mean, I've seen, you've seen the movie, Moneyball, one of the great movies with Brad Pitt that shows how big data can be used in sports. I heard another IEEE podcast that referred to big data used in law and how they change the legal profession. They can change the entire world the way we know it. In essence, our end game, if you think, is how to make better decisions. So these decisions will be made, I don't know if they will be made easier, but they could be made more optimally if we take advantage of these flexible approaches and particularly the widespread availability of data. Of course, it is a separate question. How is it better and how can we take advantage of this data better? Because sometimes the issue even of data fusion, how do you fuse all these data coming from different sources and also highly unstructured? So in that sense, there's a lot of work to be done, but it is definitely a promising field. So will it save commuting time? Sure, we hope so. And after all, we hope it does a lot of good to the environment. And so yes, we hope it will make the entire world we live in better by making better decisions and decisions that are geared towards the citizens.
Right. It's all about efficiency, right? We have these serious budgetary restrictions in many countries now, especially here in Europe. So perhaps this is a way to have better transportation infrastructures, minimizing the need of new costful investments. Do you share that?
I think it's kind of interesting and possibly amazing, a Spaniard and a Greek talking about economic and about efficiency.
Sure.
But certainly modern cities and smarter cities have to rely on lower cost and lower budget investments in new infrastructure. We have to prioritize competitiveness and improve on existing infrastructure. So I think from this perspective, I think that these technological developments will certainly bring on better decisions and a better way that the existing systems that we have in place work. And I think that's something that is very important. With all the financial constraints in general, we have no money, or that's what we know, that we have limited resources for new systems and new heavy infrastructure. So one of the ways to get around this is to better utilize existing infrastructure. So I think better analysis of the data we have will lead us to better decisions and better operations. So yes, from that perspective, I think they will be able to help significantly.
Right. Professor, in your keynote speech, you mentioned that concept, naturalistic data, related to ITS. I think this is pretty new. Can you explain that to our listeners?
Yes, I'm actually quite surprised that more people are not into this area, don't know about, they're not aware of naturalistic data, but much of it has started in the area of road safety. And it's an integration of road safety, human factors, and a lot of people from psychology are interested. Naturalistic data is a way we collect data that is natural, as it says. What does that mean? It is actual data from drivers. There's a huge experiment, the SHARP 2 in the scope of SHARP 2 in the US and a European project that actually follows a number of drivers over years in a full instrumented vehicles. Full instrumented vehicles means that they they track eye movement, head movement, blood BPMs. So they follow completely what the driver does and the reactions of the drivers on the road, and it's actual data. It's not simulator data. So that could lead to a brand new insight on how people react, what they do, and what the physiological responses are in driving. Of course, this will result in tremendous amounts of data, literally tremendous amounts of data, which I think at some point will need to be analyzed. And I think that's where particularly new techniques such as data mining or artificial intelligence will really play a key role, because the amount of information we're talking about is just mind-boggling that will come in with those experiments. And the end game, of course, will be to improve road safety.
Very well. We'll now need to make a short break, but it will be just a few seconds, so please stay tuned. Hello again. Just a shortcut before getting back to Professor Karlaftis. We are preparing a contest to thank the best follower of our show, the most active folk in terms of intelligent feedbacks, retweeting our tweets, sharing our posts, publicizing our show at email distribution lists, etc. Soon we will share the details, but you can start practicing. Remember, we need you to get to the big public, to everyone that may be interested in intelligent transportation, science and engineering. Thanks for listening, ITS Podcast. Let's get back to our interview. We're back with Professor Karlaftis talking about artificial intelligence applied to big data analysis in the context of ITS. Professor, some are saying that for fully exploiting the car traffic infrastructures, we will need to follow the triple I's, meaning that we need instruments, interconnectivity, and intelligence. In these days, for example, the mobile computing and sensing capabilities of smartphones may play an important role to you and to your colleagues working on data mining. Is that so?
Oh, yes, absolutely. Actually, I think that a smarter planet in general, if you look at it from a technological perspective, is why data mining is so useful, I think. It's when real time, because all the technologies you described can give us immense amounts of real-time data. And not only that, but this data is unstructured. So I think that all modern researchers and practitioners have to rely on the capabilities of some data analytic method that is flexible in order to make sense of such data. So yes, the information will bring upon a tremendous development in data. But again, I want to stress the point that our end game is not to collect the data, but to make a decision which requires that we analyze the data correctly. So, the data is one part of the equation. The other one is analyzing it, and the third, of course, is making informed decisions. So any development in any of the three areas will have significant impact on the rest.
Mm-hmm. And related to that, that last thing you were saying, there is that fascinating topic of onboard decision-making support systems. So they say that big data analysis is and will be playing a very important role there. But however, there is also some criticism on the implementation of such systems in our future private cars, since apparently they may bring together the need of extra training for drivers. What do you think?
Well, onboard systems for essentially for cars, and obviously their safety implications are, in my opinion, a very, very exciting field of work, research and practice. And I think, in my opinion, to be honest, the tide, if you will, of such development cannot be turned back. It has started, and it will be implemented slower or quicker. Now, from published research, it does appear that there is some cognitive fatigue and some additional training that is required. But you have to imagine all the positives. It's the same thing. Maybe, 30 or 40 years ago, there was a lot of discussion in the airline or the pilot industry about not adopting the automatic pilot because of their added complexities. But now you cannot imagine it as a single plane without an automatic pilot. So I think the tide will not turn back. Yes, onboard systems have advanced tremendously, and there's a lot of work to be done in which of those systems should be adapted, at what stage, what the training should be. But we live in a world that's constantly changing, so we have to adapt to this change. And I think that onboard systems, to the extent that I've seen these technologies or that I've read about them, they're positives on the aggregate.
Mm-hmm. Professor, it's been recently published by the journal Nature that the research team at Stanford University has made a full processor that uses only carbon nanotubes to execute the code of a multitasking operating system. So my question is, how is computing power important to big data analysis and data mining? Do you already have the computing power you need, or do you think your area is benefited by these computing engineering accomplishments?
I think that data mining and the artificial intelligence techniques absolutely depend on computing power. Actually, as a matter of fact, I think that the data analysis as we look at it these days is possible because of the computing power. Without this computing power, we'd still rely on some of the very, very classical, and some would say outdated methods. So I think those things, data analysis and computing power, go hand in hand. A few years ago, we could just run simple regression models, for example, and be happy that we could do it quickly and without having to do huge manual computations. So yes, I think data mining and some of the techniques in artificial intelligence that don't belong in the data mining area completely depend on computing power. So from that perspective, I think any kind of advances in computation, in the raw power of computers, will bring on the ability to handle a lot better the data that we have. Mm-hmm. So looking at it, of course, from an analytical perspective, all these computing developments will make a tremendous change even in the way that data is collected and processed. But I'm focusing more on the issue of how we analyze it rather than how we collect this data.
Okay. Well, you mentioned a little bit about the green side effects, the environmental side effects of this kind of techniques you use. Apart from the two more urgent goals, which are efficiency and safety, do you think that big data and applications may help out making our mobility greener somehow? Can you explain a little bit more about that?
This is an important question, and we run on the premise that better decisions that are based on better data and more advanced techniques will lead to a better quality of life. This is why we're doing what we're doing. Now, of course, I would like to touch upon I think a realization that efficiency, safety, and sustainability or greener, as you say, are frequently conflicting goals. And we have to find a way that the needs of each of this area, the economics, equity, safety, and environmental considerations need to be considered and brought together. You just mentioned previously onboard systems. The onboard systems, in my opinion, will increase safety or will have positive effects on safety, let's put it this way. On the other hand, we cannot be sure that they will not create some kind of inequities in terms of the asymmetry of who can have access to these onboard systems. So yes, we would like the systems we have and the decision we make increase efficiency, increase safety, and make for a greener planet. But this is much trickier than I think it seems at first. But yes, the goal is certainly to help with the sustainability of the transport sector.
Mm-hmm. Finally, I have to ask you about the future. What is the hot topic around the corner you foresee? Can you share what you think is going to be the next step in your area?
Okay.
if you can share it.
Well, I absolutely can. I don't know if I'm a good forecaster because, like I like to say sometimes, if about 10 or 15 years ago we would try to forecast what will happen technologically in the next year, we'd be completely off the mark. We couldn't forecast. But, I think there's some things that need to be done. The first one is that there's going to be an explosive, as there is already, explosive growth of social media. And this, and I have to repeat this is unstructured data. And a lot of that is how do we make sense of this data? How do we forecast it? How do we analyze it? Is it automated? So I think one of the big questions is working with all the social media applications. And I think this will be one of the most exciting areas, I think, in transportation, figuring out the connection between the systems we have and social media data. In terms of the analysis path, I think that we need to better establish some of the methods that are used in data mining and artificial intelligence. And I say this because we cannot shy away from criticism many times that a lot of the techniques used are black boxes, and we may not care, sometimes how the sausage is made unless it provided tastes good. But the point is that when we analyze, and particularly when we want to make informed decisions, the way in which the model has been reached and how we got the results we get is very important. So we have to work around or with the concern that a lot of the methods are black box. I think a second area, a third, if you will, is developing good test beds and test data. And I said it, I think I've said it many times, but in my opinion, you see a lot of works that say, I use this data and I reached this results. Somebody else will say I used different data and different model and I used better results. So that it makes no sense. We have to have, like they do in the medical profession, have widely accessible and indisputable test bed data that everybody can test different models, their models, on the same data. That's when we can start being a little more comfortable with the material we work with. Of course, we have to say that a lot of the data analysis approaches are data dependent. So you could, with different data, get different results. I think another area will be to use the cloud and parallel computing, all this increased power, the computing power that you said, and I think that is very important because if we are to process all this information, we can process it only with increased computing power. And of course, the cloud will bring tremendous difference in the applications and the way in which a lot of the applications are written and the way we work with it. I think a last area, and one that is close to my heart, given my academic endeavors, is education. And I think that the new era, the era that we live in, requires an education that, in my perspective, is multidisciplinary. We need a student cannot, for example, graduate from an engineering program without having a good sense of how data is analyzed, for example. Now, this does not mean a typical course only in statistics, but could mean taking some courses in economics, some courses in computers and computer science, courses in data analysis, but from the perspective of data mining. So we need to go into a world that is more interdisciplinary. You cannot be an engineer in one field and don't know how the other fields work. Computer science is an underlying theme. So I think education is another thing, and we have to rethink our programs and how we train our students.
Mm-hmm. Very interesting. Well, this is all for this interview. Professor, thank you very much for your participation in our show. I hope you have enjoyed it, and I also hope that you also enjoyed our conference. Thank you so much, and goodbye.
Thank you very much, Javier, for having me on the show. Thank you.
Goodbye. Well, this episode is over. All the good things have to end sometime, but do not worry. We will be back next month. We are already preparing a new episode with an interview that you don't want to miss, believe me. In the meantime, we will wait for your comments on this and all the older episodes. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain, soundtrack developed by Rubicon, language advisory by Manuel Arbelo. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.